Hello, sir.
Hello, sorry for interrupting, sir. There has some network issue in university campus. So I would like to request, sir, please you may start your session, sir.
Hello.
Hello, sir.
Hello.
Sir, you are audible, sir.
Screen sharing is
You are co-host, sir. You can share your
okay.
screen.
Okay. Okay, now screen is visible.
Yeah,
Yes, sir.
Okay, fine. So very good morning to all of you, and thank you very much. Thank you very much, MPK Rahuri, Department of Extension, Dr. Sapal and his team, and NHEP CAST for inviting me to address from the different campus. Those who are aspiring for preparations of the NAT, NAT GRF SRF. Hello, I'm audible?
Yes,
Hello.
sir, you are audible.
Yes, sir, you are audible.
So, this topic with respect to the ordinary least square, MLE, maximum likelihood method, estimations, assumptions, violations, property, and the simulation equations and its properties. So basically, when we are preparing about the NAT, GRF, or any competitive examination with respect to the agriculture economics, agribusiness management, the weightage that has been given to this particular chapter and particular econometrics as a whole, it's almost 9 to 10 questions you will be, on an average, you will be facing. Out of that, this OLS, MLE, and the simulations take a more weightage because these are the very frequently techniques that has been used in agriculture research for PG, for PG and PhD, and as a general whole in the agriculture economics and agribusiness management. So again, I thanks to organizer for selecting such a nice topic, and the belief that I will be able to do that particular task. Myself, Dr. Alpesh, I'm working as an associate professor in Department of Social Science, Horticulture and Forestry College of Navsari Agriculture University. First, we will start with because this is a quantitative techniques, and you may be the students generally when we are go for the statistical analysis or kind of the subject like econometrics. It's not make any kind of the rumors, but purely a quantitative analysis are there. There are some derivations are there, some calculations are there. So it is very difficult to cover this three important topic in a day or in a 2 hours. I try particularly for the exam preparation point of view, the presentation that has been made from the examination point of view, because there are lots of things are available in that. We are capturing more important point during this presentation. Whenever we are talking about the any econometric or any economical relationship, we are generally, because all the theories are based on the assumptions, and this lecture is also based on the some assumptions, because without assumptions we are not creating any economical theory. So my assumption with respect to this lecture for the students, those who are attended, the students are aware about the basic statistics, some of the basic statistics that has been we'll look at out. The students are aware about the basic concept of agriculture economics, means some of the priori theory like demand function, supply function, consumption functions, income functions, production function, cost functions. So these are the basic concept and basic theory that has been generally we are used when we are doing such kind of econometric analysis. Students are rational about the topic to be taught because we cannot think that it is not my cup of tea, but it's a rational thinking for the topic to be taught. Students may not leave the screen after joining. The thing is that some are, because it's an online mode, if it is a physical mode, then we can go for some exercise. In the online mode, students may or may not be, they are just online, they are by physically they are offline. So these assumptions can be made. Then students are equipped with all study materials. So if you are this assumption that has been taken place, then we are able to evaluate the output of this training. Even you can at the end of the session or all the session, you may be feed some of the feedback about the lecture, and we do that. But if you are giving your feedback with respect to these assumptions that they are working, then that output would be miserable. Otherwise, if any one of the assumption is violated, so our topic is also the OLS, their assumptions, their violations. Then what happened? What kind of the problem you are facing when you are going to be analyze any economic or any your research problem? So assumption is the basic fundamental things in any economic relations for explaining an economy. So suppose you are having the demand function. So demand function have a ceteris paribus assumptions, means all the other factors are keeping constants, only the price is the major variable that are affecting the quantity of the demand. So if you want to assess the output of this training, then you may have such kind of the assumptions. So for lecture, we are keeping these assumptions, and I wish that all are with work under these assumptions. Is it clear?
Yes, sir. Yes.
Okay.
Yes.
Okay. Okay. So we're starting with the regression. Basically, because generally we are using regression analysis, and everybody knows about the regression. Why the regression? Why we are using the regression? So regression terms was introduced by Francis Galton, and he simply find that some of the relationship between the height of the son and the height of the father, and he tried to get it some of the relation, and first use this regression in this terminology by the Francis Galton. So in general, we can know that there are two types of correlation and the regression. The two techniques we are using in general, even in the extension also we are using this correlation and the regression, maybe logit or probability regressions for knowing the probability. So basically regression is the relationship between two variables. Two variables is a dependent variable and independent variables. And they are trying to predicting the mean or average value of the dependent variable. So what happened in the correlation? The correlation is the finding the association between two variables. There is a wide difference between correlation and the regression. When you go for the correlation is simply that they find the association between the two variables, while the regression is the find the cause and effect relationship between two variables. This is two things in regression and coefficient. So association may be positive, negative. Regression is the cause and effect variable. So here there is one variable is a cause variable, another variable is effect variable. Effect variable be a dependent variable, cause variable be an independent variable. So between them, what is the relation that has been explained by the regression, and the Francis Galton that has been found the relationship between if the tall father have the height, tall father have a son, then his height is average. And short if the father having the short height, his son is more than average of that father. That kind of the relations he find in the regressions. So this is with respect to one thing. Important thing is here that regression is find the relation between the cause and effect variable. So what is cause, which is cause variable and which is effect variable, that has been clearly indicated by in the regression. So this is with respect to regression. Then what kind of the problem assessed by the regression in economics? Okay, then we know in our economics thesis some of the production functions are there, some of the consumption functions are there, some of the income functions are. We are finding the relationship between the price and demand functions are there, supply functions are there. So that kind of the relationship that can be explained with the because there are cause variable and there are effect variable. If suppose the effect variable was the price, then effect variable is the demand, then cause is the price. So studying the independence of the personal consumption in the consumption function, the expenditure on after tax or disposable real income, that we are going to be studying the dependency of the personal income expenditure. Want to study the rate of change of money waste in the relation to unemployment rate. At the macro level, you can do the what is the if the rate of change in the waste, then what will be the impact on the matter. A monopolist can also fix the price or output may want to find out the response of the demand for a product to change in the price. So monopolists can be know when the price could be increased, where the stock, then when the stock should be stopped. That kind of the decision that has been taken by the regression analysis. Their coefficient is tell them to what to do with respect to that particular variable and that affected variable. From the monetary economy, it is known that the other things remaining the same. The higher rate of inflation, the lower proportion of key income that people would want to hold in their money. As the inflation is going to be higher, then your holding of the money will be, because the value of the money that has been going. So that kind of the relations we are trying to assess through the regression. There are so many other relationships are there in the regression we are, but these are the important one with macroeconomics, with microeconomics, with monetary economics, with institutional economics. That kind of the relationship we are trying to find. Then the types of regression condition, the types of regression conditions. Because this is very important and many times in our examination that has been called that what univariate regression condition explain. So only the one quantitative responsible variable. In the multivariate, there one, two or more quantitative response variable. In simple, only one explanatory variable, and multiple, two or more explanatory variables. So these are the regression condition through which you can find it's a simple regression, is the multiple regressions, is the multivariate regressions, or in the univariate response with the dependent variable. In the linear regression and non-linear regression, the linear, all the parameters enter the equation linearly, possibly after transformation of the data. So we are generally, our conditions are that all the data, our model should be linear. There are some of the model, they are non-linear model, because all the conditions in the economics are not linear in the nature. So if it is a non-linear, we are trying to convert into the linear and then fix the linear model. Otherwise, directly you can fix the non-linear, but the relations between the response and some of the explanatory variable is non-linear. Or some of the parameters appear non-linearity, but no transformation is possible to make the parameters appear linearly. So there is a no transformation that has been available. So then you can go for the non-linear model. Then analysis of variance. All explanatory variables are qualitative in the nature. Analysis of covariance. Some of the explanatory variables are quantitative variable, and others are the qualitative. So with mix of the two variables, qualitative and quantitative, you can go for the analysis of covariance. You have the qualitative variable, you are for the analysis of variance. Then logistic regression, the response variable is qualitative. Logit and profit model may be applicable to that. So this kind of the condition that has been many times that has been asked in the examination, which conditions is applied for which. It may be in the tabular form, like univariate, multivariate, simple variate, and the crossing that 1, 2, 3, 4, 4, 2, 3, 4, ABCD kind of the things, and they are asking such kind of the questions. Okay, this condition is important with respect to the type of regression. So there are direct regression Hello. Hello.
Yes, sir. Yes, sir.
Yes. Whenever you feel that my voice is not clear, please indicate me. Hannah.
Yes, sure, sir.
Okay. Okay. So the type of regression is the direct regression, then reverse regression, then orthogonal regression. These three major types, there are others more types are there, but these are the important types that we are using in our analysis. Direct regression means when the vertical difference between the observations and the line in the scatter diagram is considered. You just see the graph that the sum of the point below the line, below the regression line, and some of the point above regression lines. If you are finding the vertical distance between two two point, the line and the scatter diagram, and its sum of square is minimized to obtain the estimates of beta 0 and beta naught, b naught and b1. The method is known as a direct regression. So and generally we are applying this method for getting the direct relationship between the demand and quantity of demand with the quantity of supply, the consumption function with respect to the expenditure and income. So generally we are using this method to get the vertical distance between two things. Now go the reverse or inverse regressions. In the reverse or inverse regression, the sum of square of the difference between the observations and the line in the horizontal direction in the scatter diagram, and can be minimized to obtain the estimates of the reverse or the inverse regressions. So reverse or inverse regression, here there's a direct vertical, here is the horizontal distance we are measuring. What is the horizontal distance, and that sum of square that we are trying to minimize that error, square error, and get the estimates from the regression or the OLS estimators. So that is called the regression, reverse or the inverse regression method. So only difference between two is that in both the methods we are going to be minimize some square of the mean in both the method, but here in the direct regressions with the vertical distance, and in the reverse in the horizontal distance. The orthogonal regression or major axis regression method, instead of horizontal or the vertical, if the sum of square of the perpendicular distance between the observations and the line is scatter diagram is minimized to obtain the estimates of the method of beta naught b1, known as an orthogonal or the major axis regression. So these are the three major methods that we are using during the getting the things. Now come to the method of the least square deviation regression. This because generally our topic is based on the OLS estimations, and these three types of regressions. Out of that, direct regressions is the known as the used for the OLS estimations. Instead of the method of least absolute deviation regression, consider the sum of the absolute deviations of the observations from the line in the vertical direction in the scattered diagram, as in the case of the direct regressions, to obtain estimates beta naught and beta 1. The direct regression estimates are referred as the least square estimates and estimates for the ordinary least square estimate. So anybody in any examination that should be asked that which method, direct, reverse, orthogonal, or other method, which give the OLS estimation, then your answer would be a direct regressions, and your in another terms, the vertical difference or the horizontal difference or the perpendicular difference or the square difference, what the difference that has been measured by the OLS, that is the vertical difference. If it is a reverse, then it is a reverse, then is a horizontal difference, and if it is a major axis or the orthogonal, then it should be the perpendicular distance between the two observations, between the observation and the light that has been. So in that manner, these questions would be asked with respect to this types of the regression. So we are trying to understand about the conditions of the regressions. Here we are trying to understand the what is the regressions and types of the regression. And out of that, what kind of the question that has been arised in the examinations. Okay, so we will start with the simple regression model. Whenever we are talking about the regression model, it's a very simple simple regression. Simple regression means your explanatory variable is 1 and 1 is your response variable. So that is called the simple regression. In the multiple regressions, we have already shown the condition that in the multiple regression, the 2 or more explanatory variable. Here, simple regression, only 1 explanatory variable. So simple regression, we can say that any y is equal to alpha plus beta 1 x1. So this is the simple regressions. When we're talking about the econometric concept, there are two terminology, that is the stochastic and the non-stochastic regression. So we'll look out subsequently. This model is called the stochastic model, which model is called, and why the necessary of the econometrics in the simple regression model. So simple regression model is nothing that I discussed. It is considered the modeling between the dependent and the one independent variable. As it had shown on the slide, that y is equal to beta naught plus beta 1 x plus e. So this is the simple regression model. When there is only one independent variable in the linear regression model, the model is generally termed as a simple regression model. When there are more than one independent variable in the model, then the linear model is termed as a multiple linear regression model. So both the models are said y is equal to beta naught beta 1 x1, y is equal to x1 beta 1 x2 beta 2 plus up to xk, k variables are there, and xk beta k plus e. So this is the two model generally using. We are go with the first model, that simple linear regression. How does how this can be shown? Linear regression model, one is the population model, another the linear regression equation. Y is the dependent variable, beta naught is a constant, b1 is the slope, ei is an error, and xi is an independent variable. So it is, because it's in the capital letters, so it is your y and x in capital letter, Greek letters. So it is known as the population model, population regression model, theorem, and based on this, we are drawing the sample and we are estimating one equation, that is y cap is equal to b0 plus b1 x1. Here b0 is the constant, b1 is the coefficient of the regressions, y cap is the estimated value or the predicted, and the sample data from the independent variable as a x1. That is. So we are from the populations equations, we are adopting this sample, and that sample we are running the regressions, and we are getting the estimated of that. This is the simple notations of the regression, population regression, and equation, sample regressions. Geometrically, that representation of the linear regressions, many times that has been asked in the examinations, is what is the value of the intercept? If suppose it is a consumption function, what is the value of the intercept? Suppose it is a consumption function. Consumption function means consumption expenditure is a function of income. Then your saving is your B0, because when your income is 0, the portion left out, that is your B0, the y is a, if your xi is equal to 0, suppose xi is your income, y is your consumption expenditure, then B is left out. That B is nothing but the saving. From saving, you can get the consumption expenditure. So this is the representations of the geometrical representation. So B value is the that's why B value is always above the, generally B value above the origin. The slope of the curve that has been shown by the B1, And the points that has been shown, that is some of the point below the line, some of the point observations are above the line, that are the observation value of xi. And the error EI is nothing but the distance between line and the point. The distance is, that is error. So we are on these things. The formula that y cap is equal to b0 plus b1 x1. This is if we are generally finding values of b1 and b2 and the EI, then it is called the stochastic model. Later we again see this. This is geographical simple regression model. I'm audible clearly?
Yes, sir. Yes. Your voice is clear.
So when we are going to be regression analysis, there are some of the steps, some of the procedure. We are not directly go to the model validation. There are some of the steps to do the regression analysis. First, the statement of the problem under considerations. Second is the choice of the relevant variable. Third is the collection of data on relevant variable. The specification of the model. Choice of the method of fitting the data. Fitting the model. Model validations and criticism, and using the chosen model for the solution of the problem. So right from starting, first the statement of the problem that you are having, your objectives are there. The choice of the relevant variable according to the objectives, you are selecting the variables. The number of variables are there, so you have to be the collection of the data on the relevant variable, because some of the variables are available, the data is available, some of the variable data are not available, some of the variables the data are the quantitative manner, some of the data in the qualitative. So according to your objective, what kind of the thing that you have to be covered, that you have to let down. Then specification of the model, as we say, there are numbers of models are there. Which model you are going to be linear, quantitative, translate, what kind of thing that you have to be. Then choice of the fitting the data according to the model, and the fitting the model according to your objective, and the model validation. There are so many testers there for the validations, and ultimately when you are selecting the particular model with your particular estimates, then you go for that use for the further use for the predictions or forecasting, what kind of things are over here solving your economic problems. These are the steps in the regression analysis. So we start with the sample regression equations. The basic kind of regression model is to estimate the population parameters beta 1, beta 2 from the given sample. And sample regression model is SRF, and population model function is the PRF. So SRF is nothing but y cap is equal to beta 1 cap plus beta 2. This is called the this model, this particularly y cap beta 1 plus beta 2 xi is called the non-stochastic model. How it would be this non-stochastic model? We just understand, because then why it is non-stochastic? Because when you just we could take the example of the suppose the quantity of demand is a function of price. This is the economic priori theory that has been given a statement that law of demand, the quantity of demand is a negative function of the price. This, and we can determine and we can just convert this quantity of demand into mathematical function, that is yi is equal to beta 1 plus beta 2 xi. The values of beta 1 is a plus or minus, that depends on the your observations. If so, the mathematical function then gave the exact relationship between the yi, and we are keeping the assumption that all the factors are keeping constants. So your mathematical relationship that has been given only one, because we are explaining the relationship with only the one variable. The others variables we are keeping constants. It is our assumptions, but they are not kept constant in the real situation. So that effect may be captured in your error term. So when you add these functions with error term, then it becomes the stochastic model. So your stochastic model is yi is equal to beta 1 plus beta 2 xi plus ei or ui. The population ui is the sample, it is here. So in that manner, the stochastic and non-stochastic simple regression that you can identify. When you add the error, Means you add the error in your function, that is become the stochastic. Because error is nothing but the left. There are so many reasons for the error. It may be a measurement error. It may be a poor handling of the data error. It may be a misspecification of the model error. It may be a inadequate variable adding in the model, because like suppose you are calculating the demand, but demand of any FMCG goods. Then at that time, rather than price, the taste and preference is more important, because you go to the mall or any McD or any KFC kind of the thing. So at that time, you are not looking the price, but you are looking the taste. Some of prefer to go for the McD, some of prefer to go for the KFC, some of the prefer to some Subway, some of the other brands, some of the go for the roadside kind of thing. So the taste is important rather than price. So that effect, and if you are not including the that factor, taste and preference in your model, then that can be included with the help of the EI or UI. So, and if you are including UI, then that is called the non-statistic model, the parameters. So it allows calculate the fitted value of y cap for y and xi, x is equal to xi. So we are trying to estimating the beta 1 cap and beta 2 cap with respect to the OLS model. So the difference between yi and y cap is called the residual. Means yi is your observation, y cap is your estimated from your observation. We are having two unknown parameters, beta 1 and beta 2, and third is UI. Based on the value of, we have the two known parameters, that is y cap or yi and xi. The value we are having this yi and xi, and on that basis we are estimating two parameters, beta 1 and beta 2. We are having the value of beta 1, beta 2, and we are estimating the estimated value of the y cap. So you are having the observation yi and the estimated value of y cap. The difference is this, nothing but the difference is this line and the point. So that is your the line is your y cap, your line. The point that has been above that shown as the EI cap I is your difference. This difference is nothing but error. This error is again being expounded with respect to the y cap I is a beta 1 non-stochastic model, beta 2 xi. So ultimately UI is equal to yi is minus beta 1 cap minus beta 2 xi. We can thus write this basic equations like yi is equal to, we are just making this. So the total variation in the yi is equal to estimated variation plus unestimated variation. That unestimated variation that has been taken in the UI, and we are going to be estimated UI. When in the stochastic model, three parameters are unknown, beta 1, beta 2, and UI. With the help of the y cap estimations, we are able to estimate the UI also. So then the econometrics that have been start. Here econometrics start. Here econometrics said that generally we are considering these values of beta 1, beta 2, R square, t taste, and kind of the things. But we are forgetting the error. If this variable is suppose suppose xi the variable is significant, then we are said that our model is good fit model with the good R square. But unless and until we are not looking this UI as an error, the econometrics will not come. Here the econometrics start from the beginning. So the graphical presentation, as we discussed, that this is the population regression lines, and because of the and this is the UI that I say, this is the difference between lines and the point, and we are having the equations to sum up the beta 1, beta 2, y cap, UI are the sample counterparts, beta 2, beta UI and UI respectively for the population. It is possible to calculate beta cap, beta 2 for the given sample, as I discussed. But the estimates will change for the sample. On the contrary, beta 2 are the fixed and unknown. Now, obtain the OLS estimates. How we can obtaining the OLS estimates beta 1 and beta 2. So the application of least square criterion, as we discussed, that it is we are using this minimize the residual sum of square. As to do this, we are first Firstly, going to the expressions of as sample functions, the estimators using. So minima is the as means sum of square, residual sum of square. So it is nothing but the VR summation. Minima is the UI cap square. UI is nothing but the yi as in the last slide. As in the last slide, UI is nothing but the yi cap beta 1 beta 2. So we are minimize it. So the square to minimize the as we differentiate partially differentiate with respect to beta 1 and beta 2. Then two equations that are delta as by delta cap beta 1. Then you can get these equations. And again, with respect to the beta for the partial derivations, you will get these two equations. These two equations that has been developed, and we had say that it is equal to 0. We had termed as is equal to 0 because UI is summation of UI is equal to 0, and we get this 2.11 and 2.12 equations. This is LS estimators are obtained by equating the previous derivations to the 0. So we are having two equations, 2.11 and 2.12. Both are because 2 is going to be 0 become the divided by 0, so it is become the 0. So the two equations we are having. Then estimation of the normal equations or the first least square first order conditions. In operation with the summation, these are the rules for the summations. If you are having summation A, that means you can break it out, simplify, then it is an A. If it is an A, then you can also write the summation of n with the n numbers of A. If you are having the AXI, then A is a constant, is the summation of XI. And this kind of the summation rules that have been applied in the our formula, we can just add the summation xi kind of thing. So the summation xi is equal to n because beta n. So as then beta 2 is a constant, then summation of xi. The same for the second equations. Then we are entering summation with the summation xi yi and beta 1 summation xi, beta 2 summation xi square. So that in that manner we are having this xin entering the dividing both by the and, then we are getting the y cap y bar is equal to beta 1 plus the beta 2 x bar, and beta 1 is nothing but the y bar minus beta 2 x bar. So we are having the value of the beta 1 because we are having the three unknown parameters, beta 1, beta 2 and ui. So we are getting the values of the beta 1 with respect to the OLS estimators. Beta 1 cap is nothing but y bar minus beta 2 cap x bar. By substituting this values in the second normal equations, and we have this kind of expression and solving the beta 2, so we can getting the beta 2 in 2 to 2.17 and 2.18. This summation of yixi minus y bar. We're simplifying, we get this equation beta 2 is equal to deviation from the mean for yi, deviation of the mean of xi. So this is nothing but the covariance of the two variable, summation of the covariance two variables, and divided by the square of the variance of the x variable. So this is in this manner you are getting the beta 2 value. We are having earlier we are getting the beta 1, now we are having the value of beta 2. You are implementing this, you are calculating this, and you get the equation. So dividing the numerators and the denominators by 2 by n, it can be seen that beta cap 2 is equal to the ratio between the two variable covariance and the variance of x. This is 2.18. It is ratio between variance product of the variance and the variance square of the x. Therefore, the sign of beta is the same as the sign of the covariance. Once the beta 2 is calculated, then we can obtain the beta 1 by using the 2.16. So there are the least square estimators. Since other more complicated method exists, but called the least square method, the method that we can apply is dominated ordinary least square due to its simplicity, because we can get very simply this two estimates, beta 1, beta 2, and ultimately ui. Any problem up to this, anybody? Any problem up to this? Anyone?
No, sir. No, sir.
Okay. So by example, we are trying to understand how it will be. So just go to that. Now screen is visible.
Yes, sir.
Yes, sir. Yes.
So we have the consumption functions, consumptions, beta 1 income, and we will estimate it using the data from the 6 household. So this is observations, this is observations, this is consumptions, expenditure, this is income of that particular household. And by method that we are just taking the product of the consumptions and income, we are making the square of the income. Then we are just taking the another method with the deviations. That consumption might then average means taking the deviation from the mean for each and every variable. For consumption, deviation from the mean from each and every variable of the income observation, then product of both and square of the income deviation. So in that way, we are trying to get it this
The
four.
screen is blank actually.
Screen is blank.
Yes, just example is written there.
Okay,
Nothing
okay,
is shown.
Just a minute. Just a minute. Just a minute. Just a minute. Expand it.
Please close the first PPT, then another PPT will open, sir.
It's an Excel file now. My
So-
is sharing.
In screen share, you can share the Excel file also, sir.
Just a minute.
Okay.
Just a minute. Now it's visible.
Yes, sir. Yes, sir. Now it is visible.
Okay, okay. So that as I discussed, the consumption functions, that consumption is equal to the beta 1, beta 2 income plus UI. We're having the 6 household and their consumption expenditures and the income and the unit. So there are 6 observations. This is consumption expenditure. This is the income of that particular household. We get the product of this consumptions and income, then income square. From this method, you can also get it the values of beta 2 and beta 1. Then another method with the deviation from the mean of consumption, deviation of mean from the income, and product of both the deviation and the square of the deviation of income. So we are using this also, you can get the values of beta 2. So here the values are calculated. This the first method by beta 2, that mean of that summation of the product of consumptions into the mean and divided by summation of the income square minus the income mean and into the number of products. And you can get the 8.3. You can have this beta 2 also with respect to the just simply that take the product of deviation from the mean of both the product and the square of the income, you will get the 0.83. And by 2.16 formula, you can get the values of beta 1. So, and simple another method is also that you can go for the data in Excel, data in, data, then you can go for the data analysis, then you go for the regression, simple, anybody can do that. So your Y is your consumption, your X is your income, so you are taking with the label, and simply you can just click. If you know the residual UI, then you can do the standard residual, you can show the residual plot, whatever you want to do it, that you can take it, and simply just you go for the OK. We are taking the values of X, we are taking the values of Y with the label because you are including the label, and just click OK. You can also here get it the 83%, 80 the values of coefficient 0.83, the same as the value we are calculated from the method that has been given. So here the for good fit we are go for the R square model. for the regression coefficient, we are go for the t-test and p-values. So here the t-test value is more than 2.34. So it is significant at 1%, it is 22. Your R-square is highly significant, high, it's 0.9, it's 99% of the variations in the consumption that has been explained with the selected variable. Means total variation explained with the systematic variation. So in that way, you can go for the OLS estimations for any kind. If you have the number of regression, number of explanatory variable more, you can go for the multiple regression with the same method in the same kind. So this is with respect to the how you can go for the estimating the alpha 1 beta 1, and you can also go for the residual with the help of this the simple tools of Excel. We are having this equation now. The suppose y is equal to 0.83. Y is equal to alpha's value is 1.83. 1.8 plus minus 0.83 x1 plus ui. So how we can go for the because there are many times asking in the examinations, but what are the functional forms of the regressions? Because which functional forms we are using for the analysis, because ultimately our role is to interpret the given the estimated come out from the regression analysis. So we can go for the functional form. Okay. So first functional form is the linear model. So in the last example, we are go for the linear model. Linear model, nothing but the y cap is equal to beta 1 cap plus beta 2 cap x1. Here we are not going to be differentiate or transform any variable. The simple explanation of this particular equation is that therefore is a change in a y in the unit which y measures. Suppose in the rupees expenditure, the change in the y by the unit change in the x unit change by the beta 2 value. So if it is our income example, consumption example, then if income increase, income is your income. If income increased by 1 unit, your consumption is dependent variable will be increased by 0.85 unit in the fitted function. So this is a simple unit. If you are using the linear model, means there is no transformations with respect to any variable y or x, then then explanation would be like that. The income increased by 1 unit, unit is maybe a rupees or unit maybe a anything. The consumption will be increased by that much of your beta's value unit. So this is simple one functional form. Another functional form is a log linear model. Many times examination that has been asked which explanation there has been for that. So linear model, here we are what they are doing, that explanatory variable would be transformed in the log formation. So it is linear because linear, y is your linear, log is your explanatory variable, so it is a linear log model. So its explanation would be like that: the x increased by 1%, x because it is converted into the log form, then y will be increased by beta 2 by 100 unit. So this is simple explanation we are going to be do when you are going to be go for the partial log model or the linear log model. Here we are transforming explanatory variable into the log form. We are keeping we have the same variable y is your as such, and we are regressing and the same kind of things that has been happening. And log linear model, the linear model which is given by log of y is equal to beta 1 plus x plus u. Here what we are doing, here we are converting log, we are transforming y into the log, means with the response variable has been transformations where the explanatory variable is getting such. So in that way we are going to be do. So your explanations would be, therefore the x increased by 1 unit, the y will be increased by beta 200. So you are getting this way because X is in the unit form, your Y in the percentage form. So this is the explanation that has been taken place when you are going to be using the log linear model. This is the interpretation of the beta 2 in different model when you are using which model you are using. You are in the multiple regression. Sometimes you are using log, sometimes you not using log, sometimes you are transforming in the partial, sometimes your dependent variable log. So ultimately, what the interpretations of that particular values with respect to the particular model, and that's why very clear when you are going to be study with the regression. आप कौन सा मॉडल यूज कर रहे हो वो आपको समझना पड़ेगा एंड अकॉर्डिंग टू दैट योर इंटरप्रिटेशन वुड बी like that. So this is the important things, and many times that has been asked in the examination. Okay, then we are going to be the properties of OLS as discussed, that it is a blue properties of OLS. Many times that has been asked in the what is the blue that we are going. The first properties of OLS is unbiasedness, means estimated beta cap minus beta means population parameters. If bias means estimated beta cap minus beta, that is your bias. Means the value which were estimated is not equal to your parameter, is not representing your parameter. So there are some difference between them. So that is called the bias. When we are talking the unbiased, when the estimated beta is equal to beta, your parameters is equal to your estimated beta. So that if you can get it, this then it is called the unbiased properties of the OLS estimate. This and a very important property is unbiasedness. It will be used in maximum likelihood method, in simulations equation methods. Then second is the minimum variance square or the best estimator. Minimum variance square as or the best estimator. When you call the best estimator, when your error, that your mean square error is smaller than any other method from which the estimated can be done. Means if you have the two method, OLS method or any other methods, so your the OLS method's minimum mean square is less than any other estimates of the variance of the method. So then you can the best estimate. So we are having two properties, unbiasedness and best estimator. Best estimator, when you call that, the estimator is the best when it the smallest variance as compared with the other estimated from the other econometric method. Means your OLS methods estimates smallest variance is compared with the other methods variance. And if it is the smaller, then it is called the best estimator. So we are turning out the blue properties. When you call the efficient estimator, an estimator of the OLS is efficient when it possesses both the properties, unbiasedness and the minimum variance. In the your estimated like beta 1, beta 2, beta 3, you have the multiple regression, then it has the both the properties that your estimated beta beta is equal to your parameters beta, and your variance is also should be a minimum. So if you are purchasing property 1 and property 2, it is called the efficient estimator. And many times the examination that should be asked, what is efficient estimator? And when it is called best estimator, then it's the smallest variance is as compared to the other method variance. Yeah. Everybody get it? Any problem?
No, sir.
Okay. Any problem you can raise to the host. So we will discuss. Then linear estimators, another fourth parity, that the linear estimate, the OLS estimate is linear if it is a linear functions of the sample observation, that it is determined by the linear combination of the sample data. So your estimated is also should be a linear as I discussed. Then based linear unbiased estimator, based linear unbiased, that is called the blue properties. If your estimates this beta 1, beta 2, beta 3 has possessed this property, based means the variance is minimum than other method. Linear, it's a linear functions. Your observation in the linear manner. Unbiased means your beta is the beta cap is equal to your beta. That is, if you are having these three properties, then it is called the blue estimator. Estimator, efficient estimator, when you are having both the properties, best and unbiased. So the best is nothing best linear unbiased estimator. An estimator's OLS at beta cap is blue if it is a linear, unbiased, and the smallest variance as compared with the other linear, unbiased estimators of the true beta. The BLU estimator has a minimum variance within the class of linear, unbiased estimator of the beta. So minimum square error or testing are also one of the properties with respect to that. So minimum square criterion is a combination of the unbiasedness and minimum variance property. Means it is again the combinations of the minimum variance and unbiasedness of the estimators is MSE. The estimator is MSE estimator if it has the smallest mean square defined as the expected value. So both the formula that has been given, the variance there, then you can say that it is a minimum variance, minimum mean square error MSE. So in that way, this blue property, if you are having the blue, is unbiased, the beta 1, beta 2, it is a linear also, and it is a estimator. So blue property, your unbiasedness estimated. That is called the blue property. Okay. So this is the properties of OLS. Now we turn out to the assumptions of OLS. Assumptions of OLS with respect to taking this first is the assumptions, then is the violation, then what happened. So in the lecture, this presentation we are trying to combine first the assumptions. So there are stochastic assumptions of the OLS. There are two types of assumptions: stochastic assumptions and then non-stochastic assumptions. Stochastics, as I discussed, because the stochastics assumptions are related with respect to your UI or EI. That's why it is called the stochastic assumptions. Non-stochastic assumptions, we are with respect to the other parameters for the estimates. So stochastic assumptions of the OLS, these assumptions are about the distributions of the value of UI. The assumption of UI is first is the UI is a random real variable. First is the random real variable. So we say that the UI estimated from the y cap, these variables are random and real because it's contain all the other variable which are not included in the model. It contains all the other errors which are not included in the model. So that is called the random real. The value of UI may assume in any period depends on chance. It may be positive, negative, or zero. And there is no particular pattern that has been assumed in any UI. So each value has a certain probability of being assumed in UI in any particular case. So the distance between this with respect to that your line is maybe not in the same line. There's 5, 5, 5, 5 or minus 2, 2, 2, 2, but it should be some random disturbance. So sometimes the observation would be above the line, and sometimes below the line, or some are is on the line. So the dispersions will be random. If the error exhibited a symmetric pattern, then the assumptions of randomness is violated. Means any systematic pattern that has been observed in the error, like suppose in the time series data, some of the value that you are having some seasonal trend or the annual trend, then this trend is creating problem in the analysis. So we assume that it should be a random real variable. And in the particular econometric relation, when the study is important explanatory variable, then the error will not show the random pattern. And in another case, when you miss the any particular important explanatory variable in the model, then that kind of the situation that is arising, and you can solve. Then assessment to the mean value of UI in any particular period is 0. This is very important assumptions in the UI. The mean of UI is equal to 0. Means because some of the when you go for the UI, you are getting some of the positive value, some of the negative value, and the mean of this value, it should be a 0. So for each UI, the means of each mean for the each value of xi, UI may assume various value. Some are positive, negative, but consider all the possible value UI for any given value of x, they would have an average value equal to 0. If assumption 2 is, if suppose there is the mean is not equal to 0, then what happened? If suppose mean is not equal to 0, if suppose UI is greater than 1, means the majority of observations of y and x lies above the regression line. Means, just I can give you the idea. Okay, if it is above the 0, then what happened? That majority of the observations above the line, majority, hardly 1 or 2 observations or the few observations out of 100 that should be below the line. So it is a positive. If it is a negative, less than 0 mean, that means all the majority of the observation should be lies below the line. So in that case, what happened? It should be a bias. It should be a bias. So the assumption is very clear cut that the mean of it should be a 0. It's not the above or not the below. So the negative and positive value should be it should be a 0. So this is another assumptions. So first assumption is a random real value. Second is the mean of UI is 0. Then third assumptions, the variance of UI is a constant in each period. The variance of the UI is a constant in each period. The meaning the random variable UI is that its probability distribution remain the same over all observation of x, and in particular that the variance of each UI is the same for all the value of the explanatory variable. Symbolically, the variance of UI is equal to constant. So sigma square should be constant as shown in the figure. Income density means income consumption function. This assumption is known as the homoscedasticity or the constant variance assumptions. If anybody asks what is the homoscedasticity is nothing but your variance of UI is equal to constant. Means it should be throughout the values of xi, it should be a constant. So meaning the homogeneity is that the variance of UI around its 0 mean does not depend on the value. So your variance sigma square is not a function of xi. Means it's not a function of xi. If your variance is function of xi, that is the case is a different case. If it is a not function of xi, then it is a constant. So it is the case of the homoscedasticity. If the violation set assumptions 3 means the constant variance, your sigma means your sigma square is a function of xi, then it is called the heteroscedasticity. So what happened? So UI is the conditional variance of yi are no longer constant. Means as shown in the figure, some of the the dispersion of UI is higher, some of the lower, some of the disperse very low, and in that case your variance is not constant as shown in the above first figure. And it shows that the sigma square is a function of xi, that is called the heterodiscussion. So there are, if the constant the assumption 3 is violated, the cost of then is caused the heterodiscussion. The source of the heterodiscussion, how the heterodiscussion come in your analysis? Following the error learning model, as the people learn, their errors of the behavior become smaller over the time, like measurement error. If you are typing, if you have initially you are typing, if you are having, suppose you are going to be enter the 5,000 data, and you are very not fan of your computer. Your computer is new, you are not having the idea about the feeding. Then initially you are making initially in 100 or 200 data, you are going to be making more measurement errors. Sometimes you're writing 50, the observation is 50, you are writing 51. Sometimes your observation is 5, you are writing 0.5, and you are 50, then you are typing 0.5. So that the measurement error or the typing error that has been removed. As gradually you are going to be continuous feeding, then your error should be minimized. So the one source is the error. Then heterodiscusity can arise as a result of the presence of outliner. As I discussed, there's some of the either in the feeding or in the observations. Some observations having a very high value and some of the very low value, which is not under the area of all the observation. Then outliners may be create heterodiscusity. The heterodiscusity arises from the violating assumptions of the regression model is correctly specified. Then also assumption that is heterodiscusity arises if the presence of skewness in the distribution of the one or more regression included in the model. Then David Henry notes the heterodiscusity can arise because of the one incorrect data transformation, the ratio or the first difference transformation, and incorrect functional form like linear versus log linear model. So these are the different sources from which the heterodiscusity is coming into the model, and homodiscusity cannot exist in the. So what are the consequences with respect to heterodiscusity? We cannot apply the formula of the variance because in the variance is not constant, so it is high of a coefficient to conduct the test of significance and to construct the confidence interval because variance is high. If UI is a heterodiscusity, the OLS estimates do not have the minimum variance property means it is not based, it is not efficient because both properties are not being met. In the class of the unbiasedness estimators, the prediction of the variance include very high variance of UI. Thus, prediction of Y on X is inefficient because high variance is there. It creates some of the problems in the prediction. So these are the consequences that has been arise with the if you are with the heterodiscusity model. The test of detections of homodiscusity, the Spearman correlation test, Goldfield quadrant trace, Glaser test, and the PAR test. They are the tests that has been used for the detection of homodiscusity. The remedies of heterodiscusity, the transformation of data, and it's dependent on the exact nature of the association between the error and X. Means it should not be a function of X. We are trying to do that. If it is established the E square is directly related to Xi, all the variables are to be divided by the square root of Xi. That is one of the methods through which you can try to reduce your heterodiscusity and get it the homodiscusity data. We have two remedies. The fourth assumption is the variance of UI has a normal distribution. The value of UI for each value of X have a bell-shaped symmetrical distributions about their zero means. To summarize, this for all the four assumptions summarize UI is a random, normal with zero mean and constant variance. How it can be read? The UI is a random, normal, zero mean and constant variance. This equation, this can be read as, and many times there has been in many examinations that has been asked. Sometimes they are using different sign, or sometimes they are using different things for that. Up to this, it is okay? Hello?
Yes, sir. Yes, sir. Yes, sir.
The fifth assumption, the random terms of the different observation U and UJ are independent UJ means that their covariance is 0. If this assumptions, if their covariance is not 0, then there is problems of the autocorrelation. If violation of this assumption, if this assumptions, first we are heterodiscusity, if the constant is not a constant, if UI and UJ are independent, in the time series data, what happened that your legged variable is correlated with your preceding values correlated with your succeeding value. So that kind of the UI and UJ are correlated to each other. They are not independent to each other. But the assumption is that covariance of UI and UJ is equal to 0. If this assumption is not fulfilled, then the problem of the autocorrelation that has been prevailing in the model. So if the assumption of fifth is not satisfied, that is the values of UI in any particular period is correlated with the own preceding value or the values what say there is an autocorrelation or the serial correlation or the random correlation. So very simple with respect to the autocorrelation. The word it should be look like a very hard, but the very simple thing that your the UN uses covariance of UN uses is not equal to 0, that is autocorrelation. If it is 0, that is non-autocorrelation. So autocorrelation is a special type. The correlation is referred to the relations not between the two or more different variable. This correlation is not between the two different variable, but the successive value of the same variable. So ut is equal to eta ut minus 1 plus vt. This is the form of the autoregressive relationship, and OLS that is that eta cap is equal to summation of eta into et t minus 1 divided by summation. This is the autocorrelation function. Source of autocorrelation: the most of the Agril Economic time series variables are autocorrelated in the sense that the values are related to the past value. In the most secondary source, often some interpolations or smoothing is done. In such cases, there is a likelihood of the presence of autocorrelation, means there is a chance of autocorrelations in the secondary source, because some of the data we are using secondary data. These data sometimes is aggregated, sometimes they are using some of the method like indexing data we are collecting, then smoothing, interpolation kind of things are there. So that kind of the data that may be with the autocorrelation. Many times series data have a cyclical behavior. In such data, if linear growth model to explain the change in such a variable, which is cyclical pattern, it may find the error to be autocorrelated. In agriculture crop failure, due to the drought affected performance of many economic variable in many following years, the disturbance term truly serially correlate. So there are trend, seasonality, and irregular trends data. They are, if you are using such kind of the data in the time series, then you may find the problem of autocorrelation in the time series data. Why it should not be in the cross-section data? Because cross-section data, generally we are finding the multicollinearity and heterodiscussion problem. But almost because in time series data, only the autocorrelation problem that has been found. So test for the presence of autocorrelation would be the graphical pattern. You can go for the pattern of your data and you can easily identify it. And the Durbin-Watson test that has been test that has been confirmed in the autocorrelation. The consequences of the error, consequences of autocorrelation. So whereas estimators of the parameter are still unbiased, even though the OLS estimates for parameters are still unbiased, but estimates of the standard error are large, not minimum, means the variance is going to be very high, than those obtained by the other method, if you are doing your autocorrelated data. Sampling variance, the error or residual sum of square is underestimated. So again, it will create a problem. And the prediction based on the OLS estimates will be inefficient. So a prediction with the autocorrelated time series, then it should be inefficient. It will not be a good fit for the model. Remedies: identify the possible omitted variable and regress the residual ET on this omitted variable and re-examine this residual. You can ET on X0T and omit the variable. Identify the possible misclassification of the model regression ET on higher power of the expected variable. Re-examine this residual. Hello. Check for the possible measurement error in the dependent variable. If all the above will not work and still autocorrelation exists, then transformations of the original data and produce model whose random error is not autocorrelated. Generally, we are transformations. Generally, we are taking the first difference data, two difference, second difference data, and gradually, if it is not, then the third difference data. So, transformation is the better idea to remove the trends or seasonality or the cyclical behavior from the data. We try to remove the autocorrelations. If the omitted variables are some of the variable important that are omitted, you can include in the model, reduce with the regress with that, and you can find them. Otherwise, you can omit it. So these are the different method of the remedies autocorrelation. Then assumption 6, the autocorrelations. That's actually valid. So the disturbance terms is not correlated with the explanatory variable. The UI, the U's and X do not tend to vary together as a covariance is equal to. It's a covariance if the X and UI is equal to 0. The first is the UI and UJ covariance is equal to 0. Second assumption is the covariance of X, means there is no relationship between the two variables. UI, the error that's been emerged from the X and Y observation. So there is no relation between the independent variable and the UI. There is no relation between the UI and the succeeding value of the UI and UJ, and both the covariance will be 0. Seven, the explanatory variables are measured without the error. This is other assumptions that has been taken. If the UI absorbs the influence of the omitted variable and possibly error measurement in Y's, that is will be assumed that regressors are error-free, while Y values may or may not be include error of measurement. So this is another assumptions for the UI. These all are the assumptions are up to 7. These all are the assumptions are called the stochastic assumption, because all assumptions are based for the UI. The non-stochastic assumptions of OLS, the explanatory variables are not perfectly linearly correlated. Means the correlation between Xi and Xj is not is equal to 1. If it is equal to 1, then it is a perfect correlation between Xi and Xj. Means suppose you are having the multiple regression model y is equal to x1, y is equal to alpha plus beta 1 x1, beta 2 x2, beta 3 x3, beta 4 x4. It says that there is no relationship between x1 and x2, x2 and x3, x3 and x4, x4 and x2, x4 and x4 and x1, x4 and x2, x4 and x3, x2 and x4. So all the combinations, there was no correlation between exist. Our assumption is that if suppose that correlation that has been exist, then it is a case of the multicollinearity. If the assumption is higher than violated. So if there is a more than one explanatory variable in the relationship, it is assumed that they are not perfectly linearly correlated with each other. Meaning explanatory variable are not perfectly linearly correlated with the Rxi xj is not equal to 1. If the explanatory variable are not intercorrelated at all, the correlation coefficient of this variable is equal to 0. The variable are called the orthogonal variable. And there are no problems concerning estimates of the coefficients. Means there is no problem to concerning with to estimate the estimates of the coefficient. Directly you can go for estimation. You can just check out the correlation between the different dependent variable. If they are showing the orthogonal correlation, then you can directly say there is no problem to go for the test of anything else. If there is a suppose there is a case of the means Rxi is equal to xj is equal to 1, then the violation of assumption. If in a model more than one variable in the relation we show the perfectly linearly correlated means Rxi xj is equal to 1, this is a case of the multicollinearity. So 3 cases that has been emerged from the OLS assumption. First, heterodiscussion. Second, autocorrelation. Third, multicollinearity. And parameters become the indeterminate as it is impossible to obtain numerical value of each parameter separately, and method of least square is breakdown. If suppose there are the correlation exists perfectly linearly correlated, then it is very difficult to determine the estimates for that particular regression. What are the consequences? To estimate the regression coefficients are indeterminate, the multicollinearity is perfect. The standard error of the regression coefficient are inflated, which makes result less or precise. OLS estimates are unbiased, and coefficient of multiple R square to be very high. So when you get the high multiple correlation coefficient than or multiple determination coefficient, then you will be very conscious with respect to your variable. How will be testing? The E Farrar and the R global test. The practice consequences analysis is also there. If suppose you are adding the variable in your equation, you can find the high R square. A new added new variable in the model classified as a useful, superfluous, and determinate. Many times examination that has been asked. If new variable improve R square without rendering the individual coefficient and unaccepted on priority consideration, the variable considered as a useful and retained in the model. If new variable does not improve the R square and does not affect any consideration extent, the value of the individual coefficient, it is considered as superfluous. Meaning this does not affect the R-square, does not improve as well, also not, does not affect any consideration extended to the value of the individual coefficient. If a new variable affect considerably the sign or the value of the coefficient, it is detrimental. Take decision based on the how much it affect to the other. So these are the three Brexit confluence analysis that has been asked many times. Remedies: increase sample, substitute legged variable for the other explanative variable in the distributed leg model. Use distributed model. Introduce the additional equations of the model. Application of principal component analysis for the selection of the variable. Application of the incorporating extragenous quantitative information. The method of pooling or cross-sectional time series data. Method of restriction least square. And mixed estimation techniques proposed by Thiel and Goldberg. So these are the various remedies that you can remove from the multiple coding. Okay, this is with respect to OLS that we have been completed with respect to the properties, their assumptions, their violations, and kind of. Any problem in this up to that? Because we have already only 30 minutes are there left out. Any problem, participant? Anybody?
Sir.
So we can. Yeah.
No, sir. No, sir.
So everybody with the assumptions of the lecture, initially I was with you.
Yes, sir. Yes, sir.
Okay, this is with respect to the OLS. OLS, when you go for the OLS estimation, these are the problem. If these are the assumptions you have to check with respect to your UI, and there are some of the if it is violated, that the heterodiscussion, multi-collinearity, autocorrelation kind of the problem may be arise. And you can also identify that in the model in any analysis. You can also with the different taste model, you can also find the presence of the multicollinearity, autocorrelation, heterodiscussion, and you can also go for the remedies and doing the your equation would be give the better explanation of your suggested problem, studied problem. So this is OLS method, ordinary least square method. Now this another method, that is simultaneous equation method. Before starting this, I would like to be say, because we are studying the economic relationship in general, and initially I just want to if anybody can give me what is regression, just earlier that we discussed. If anybody, what is regression? We discussed that things. Anybody can give?
Sir, it is the functional relation between two dependent and independent variable.
Okay. Anything else you can add it more? It's a very, very nice. It's a relation between two dependent and independent variable. What we are going to be do that in that?
It is a cause and effect relationship. It shows the cause and effect relationship.
Yes. It is a purely a cause and effect relationship. So we are identifying what is cause, what is effect. And according to that dependent and independent variable, we are deciding. So this is very simple with respect to the regression. Which relationship regression explain? That is cause and effect relationship that I will give you. Which relationship regression explain? Cause and effect relationship. Okay. Now, what is cause and effect relationship? Anybody can respond these three questions. What is cause and effect relation? How to identify variable is cause and or effect variable? And what the stand for not identify cause and effect variable? Anybody? Anyone? Because it is based on the previous OLS based, or we have because I have covered that things to do that. Because suppose there is a quantity of demand, and we are economic students, so we know that because the layman, you can go for the layman. The quantity of demand is a function is directly affecting the price. The determinants of demand, you can take it any determinants of demand, income, function, technology, fashion, or any and you can also have in the quantity of the demand. So that how you can find this, which one is the cause or which one is the effect? What is the criteria for identifying the cause and effect relationship? Or it is a cause, it is an effect?
So price is the cause and effect will be on the demand.
Okay, so as we know that price is a cause and the quantity is a effect. Okay, yeah, that this is a simple case we know. If suppose in some commodities and some relationship, you may find that the law of demand does not exist. So there are exceptional of the law of demand. In that case, we are identify this is cause and this is effect. Sometimes is the demand, price is not directly affect to the demand. Means sometimes demand increasing and the price also increasing. So at that time, price is because of the price increasing, demand increasing. In many times. Okay. So in that cases, we are not identifying what is cause and what is effect. So when there is because in economic, in the pure science and the life science, what happened? We are generally identify the unidirectional relationship. There are two types of relationship, unidirectional and the bidirectional. Generally, life science having the unidirectional relationship means that cause and effect that has been very well explained. This is cause, corona is a cause, virus is a cause, and this is effect. So there is a in the life science, the cause and effect variables are already been explained. But when you come to the economic or social science, and they are unidirectional, they are called the unidirectional relationship because dependent variable assumed to be caused by the controlled variation in the explanatory variable is called the unidirectional relationship. So this kind of the relation should be observed in the life science where the cause variable and effect variable are almost fixed or easily identified. Now, how to solve this problem of the bidirectional relationship? When there is a bidirectional relationship, means sometimes your causes become effect, sometimes your effect is become cause. So sometimes independent variable become the dependent variable and dependent variables become the independent variable. So that is called the bidirectional relation and many economic relationship that has been observed. In social science like economics, it is very difficult to explain cause and effect relationship because we are having the law of demand, but we are just we are just say that the exceptional of the law of demand because of the intervention of the advertising in the Powell model, there should be another relationship you may find. So it is difficult to explain the cause and effect relationship in many economic relationship. To explain the bidirectional relation or two-way position relationship. In such situation, does not explain with the single equation model. Means when there's a dependent is independent, sometimes independent becomes dependent. In that situations, we are not explaining the situation with respect to the single equation, means a unidirectional equation. To solve this problem, like to present two-way flow of the influence among the variable, specification of the system of equation describe the causality of each variable separately become access to the simultaneous equations. So when the simultaneous equations come, when there is a two-way or the bidirectional or the two-way coefficients effect has been found in the variable. Is it clear? When simultaneously we are using, when there is a two-way or bidirectional causality has been found in the equations, in the situation, rather than equation, it in the situation. So understand by example that there is a demand, the quantity of demand is the function of the price. So the quantity of demand is alpha 0 plus or minus alpha 1, PT is the price and UI is your R. So we can identify equation based on the sign of the alpha 1. This equation is the demand equation of the price you can divide easily in the unidirectional relationship directly you can find. But sometimes the quantity of the demand increase, the price will be unaffected. That can happen in many times. Meaning the law of demand does not exist. Thus, in some case, price will be affect the variable demand, variable and the demand will be cost variable. And the question arises that would be which affect which. Shall sometimes price affect the quantity or the quantity affect the price. That situations may be arise. So it is very difficult to identify these situations, which affect which. Do you understand anybody?
Yes, sir. Yes, sir.
Okay. So another we can situation like we can suppose you have a demand function and the supply function. The two functions where the quantity of demand is alpha, is alpha 1. The same with the quantity of beta. So functions are both are looking the same. Alpha demand function and supply function, just their parameters alpha 0, beta 0, alpha 1, beta 1 are the different with u1 and ut. Okay, we are taking the convex combination of these two functions and this lambda multiplied by demand functions and 1 minus lambda is multiplied with the supply functions where the lambda is equal to between the 0 and 1. And now added the combinations, so you can have the combination and the qt. We are combining this both the and we are trying to get in the ideas of the symmetry equations. This qt is the lambda alpha 0 plus 1 minus lambda beta 0 plus lambda alpha 1. Just we are multiply lambda with the demand function and 1 minus lambda with the supply function and this equation that has been formed. And we can form new equation that qt, the quantity is the gamma 0 plus gamma 1 pt plus u3. Here gamma 0 is nothing but gamma lambda 0 plus 1 minus gamma beta 0 means intercept. We are just intercept of the both the demand and supply functions. Your gamma 1 is nothing but the regression coefficient of the demand functions and the supply function with the convex combination. And u3 is the same with respect to the u3. So, and we can again draw the same function like demand and supply, that is qt is equal to gamma 0 plus y1 plus pt plus u3. Now statistical problem come with this function, with the convex combination. What kind of statistical problem that has been come with respect to? We collect the data related to variable under the study of the quantity of demand of a particular commodity and its price over the period from the market and analyze the slope and intercept. So it's very simple. Here we can, with the OLS method, we can just simply this slope. Slope is nothing but the covariance of the two variable, product of the covariance of the two variable and divided by the product of the dependent covariance of the independent square. And intercept you can measure. So now what happened? Now the statistical problem with the convex combination is that because we are estimating from this equation gamma, so what does the what the slope? It's the it for alpha, it's for beta, it's for alpha 1 or it's for beta. Because here is the quantity and here is the price. We may say that if the slope of the positive, if the slope is the positive, then beta 1, then it should be a beta, means it is a supply function. But sometimes not true, demand have a positive relation with the price, so it may not stand for the alpha. It may stand for the alpha 1 also. So we are not sure that it may be the demand function or it may be a supply function or the convex combination from that particular equations that derive the slope and intercept. Same stand for the intercept. Thus, it is called the problem with the identification in the simultaneous. In the simultaneous equation, very important is the identification problems. Here we are covering these few points of the identification. Solve this problem with the this identification with the simultaneous equation model. Few terminology that has been asked and many times in the examination. That is, first is the endogenous variable and how define the endogenous variable and the exogenous variable in the model. The variable which are explained by the functioning of the system and values of which are determined by the simultaneous interactions of the relation in the model are endogenous variable or the jointly determined variable. Exogenous variable are the predetermined variable, the variable that contribute to provide explanation for the endogenous variable and value of which are determined from the outside the model are exogenous variable or predetermined variable. Exogenous variable help in explaining the variation in endogenous variable, as we can consider the independent variable. It is customary to include past value of endogenous variable, means legged variable, in the predetermined group. Since the exogenous variable are predetermined, so they are independent of disturbance in terms of the model. Means they are independence, means xi and uj, the covariance is 0. Exogenous variables are explained by functioning the system and the value which are determined by the simultaneous interaction. Means they are directly functioning the system and the values of the things. So in that way, the jointly determined variable, they are endogenous variable, independent or predetermined variable are the exogenous variable. So from the model, we are trying to determine which are exogenous and which are endogenous. So let another example, let denote the demand of a commodity, say that wheat at time t, dt, st demand or a supply of the commodity, say at time t, qt denote the quantity of the commodity, say wheat, transacted at time t. Means it is the demand or supply that we will be looking at the later. The economic theory about the ideal market, we have the following condition that dt is equal to, means in the equilibrium condition where the demand is equal to supply at time t. So you are having that equilibrium position. In that condition, what happened? The demand for wheat depends on the price of wheat at time t and income of buyer at time t, because it's a consumer function. Supply is the producer function, the price of wheat at time t, and rainfall because it's the production function. Because if a good rainfall, good harvest, and so the supply is based on that production point of view, the rainfall. From the market condition that quantity demand is equal to supply, that quantity of demand is equal to quantity supply of that particular quantity and particular price. So demand, supply, and price are determined from each other. Income can influence demand and supply, as it discussed. But demand and supply cannot influence the income. Means demand बढ़ेगी या supply बढ़ेगी, तो हमारी income बढ़ेगी नहीं. That cannot be possible. But your income, if it is increasing, so your demand and supply is affected. Just keep it in the mind, because we are trying to identify endogenous and the exogenous variable. Supply is influenced by the rainfall, but rainfall does not influence the supply of the wheat. And we cannot say that the wheat production is increasing, so the rainfall is going to be increasing. Our aim is to study the behavior of supply, price, and rainfall with the determined this equation. Since the endogenous variable are influenced by the exogenous variable, but hello, yes. Yes. Hello. Anything else?
No, sir. No, sir. Please continue, sir.
Okay. Since the endogenous variables are influenced by the exogenous variable, but not vice versa. So ST, PT, RT are endogenous variable, and IT and RT, means income and rainfall, are the exogenous variable. As our condition, the variable which are explained by functioning of the system, these variables endogenous estimates the system, because they are sometimes endogenous, they are sometimes exogenous. But rainfall and incomes are the exogenous variable, the predetermined. So in that case, we are just identifying for the equation what are the endogenous. First identification that has been completed. So now the legged price are rated to affect the demand and supply equation, both operating both the models. So we can now write the demand depends on PT, I, and PT minus 1. Supply also PT, RT, and PT minus 1s. So endogenous variable is the PT, DT, and ST, and exogenous variable PT, I. The mechanism of the markets is now described by the following set of equations: that demand is the A1 plus B1 PT plus CT, ST as a supply E2, B2. Equilibrium is demand is also. These equations are called the structural equation. The error EI and E2 are called the structural distribution, and the coefficient A1, A2, B1, B2 are called the structural coefficient, and the system of equation is called the structural form of the model. Is it? These are the terminology that has been asked. Now, the statistical point of view, we would like to be write this model in such a form, the OLS. We directly arrived writing the equation 1 and 2, that PT and quantity from the OLS, that for both equating both the equation and this quantity we have. Each exogenous variable is expressed as a function of the exogenous variable, with each endogenous variable is expressed as a function of endogenous variable and not the exogenous variable 1. This x1 is equal to 1 and x2 is equal to 1 is not clearly identified. The equation 3 and 4 are called the reduced form of the function, this third and fourth. And in general, they call the reduced form of the model. The coefficient of the pi 11 and pi 21 are called the reduced form of the coefficient, and error Vt, V1t and V2t are called the reduced form of the disturbance that explained in the model. Now note that the reduced form of the form essentially expresses every endogenous variable as the functions of the exogenous variable. This will represent a clear relationship between the reduced form coefficient and the structural coefficient, as well as between the structural disturbance and the reduced form disturbance. The reduced form is ready for the application of OLS techniques. You are directly applied for that. And the reduced forms of the model satisfy all the assumptions needed of the OLS, as I discussed in the earlier. By this example, the following has been described up to now: structural form relationship, reduced form relationships, need for the reduce the structural form into the reduced form, and reason for the identification. So again, the problem of the identification, when you are applying to that, we can go. Identification, problem of identification, there are three types of identification: under identified case, exactly identified case, and over identified case. Under identified case means the estimation of the parameter is not all possible in this case. No enough estimates are available for structural parameter. Exactly identified case, the estimation of the parameter is possible in this case. This estimation of parameters are possible in this case. The OLS of reduced form coefficients lead to unique estimation of the structural coefficient, and in the over identified case, the estimation of the parameter in this case is possible. The OLS of reduced form coefficient leads to multiple estimates of the structure. This will be understood with respect to the example. The estimation of SME, the simulation equation model, OLS assumptions 10. This thing, OLS as what is OLS assumption? OLS assumption is your unbiased property. Means estimation of beta cap is equal to your beta is an unbiased property have the OLS. But when you go for the simultaneous equation, you will not find this property. Your beta is not equal to your parameter. Meaning the bias relationship and unbiased is not hold true. It become biased and inconsistent estimate. So when you go for the simultaneous equations, this is the thing, directly you can go for that. Then you may find the bias and inconsistent estimates. So what are the method of simultaneous equation? Single equation model and system methods. What are the single equation method? Indirect least square method, ILS. The method of instrumental variable, two-state least square method, 2SLS, limited information maximum likelihood, LIML, mixed estimate method, three-state estimate method, full information maximum likelihood in the system method. So these are the methods that have been used in the estimations of the simultaneous equation. First, we will look at the indirect least square method, the properties, the unbiasedness, unbiased and consistent estimates of the reduced form of parameter. You can get it. Means reduced none as a recursive model, and reduced form gives the unbiased property and the consistent parameter. If you go for the reduced form as we discussed, then you will get the unbiased and consistent parameter, then other method. The biased but consistent estimates for the structural parameters. It may be a biased but consistent parameter you will get. It is not fully efficient estimate. So you will not get the fully efficient. It is appropriate for the exactly identified equation identification. When you have the exactly identified equation, then you can go for this. How to find the exactly order of that. If k minus 1 is equal to x, k minus 1 means excluded variable, and g minus 1 is equal to total number of equation. Means how many variable excluded, that is k minus 1, and g minus 1 means total number of equation, how many equation in your system. If k minus 1 less than g minus 1, then it is identified as an under identified equation. If k minus 1 is equal to g, means excluded variable is equal to total number of equation, the exact identified, it is called the exact identified equation. So your indirect least square method is identified as an exact identified. If k minus 1 greater than g minus 1, if more than that, excluded variable is greater than total number of equation, then it's an over identified situation. So in this rank order identification, we are going to be identifying the model with the method. The two-stage least square method, 2SLS, it is very important method. As well as I said that these three methods are very important in the simultaneous: the indirect least square methods, two-stage least square method, and system equation, three-stage least square. Developed by the H. Thiel and the R.L. Bisman. It is extension of the LSS method, least square method. It is aim to estimate the simultaneous equation, aim to bias. It aims to estimate the simultaneous equation bias. The estimates from the small sample are biased, but from the large sample, the bias will be 0. So with 2SLS, if you are measuring with a small sample, should be biased, but you are increasing your sample and it gradually it will become the 0. So in the last sample, this method will be very much useful. And 2SLS model is applied in both just identified and the over. Just means the exact. Just means exact. Exact identified and the O and the over identified means this method is having the two criteria. Just a minute. 2SLS model gives efficient estimators if OLS method is failed, where OLS method is failed, and two SLS methods give the consistent estimates. 2SLS use predetermined variable, exogenous variable, and the endogenous linked variable. But in these conditions, so there is a good property of the 2SLS model, and it will be asked many times in the examination. Limited information maximum livelihood method, LIML, is based on the 2SLS because it's both method used for all the predetermined variable. LIML is used if the equation is over-identified, as in the case. LIML method gives consistent and efficient estimators. Estimators from the LIML methods are biased and consistent. A small sample is biased and consistent with the large samples unbiased. This is both the method. 2SLS and LIML with the scope of very good unbiased and consistent in the large sample. Three-stage least square method, 3SLS given by the Thiel and Zener. Three-stage least square method applicable to all the equations at the same time. Three-stage least square method system is for the over-identified. Three-stage least square is the extension of 2SLS. 3SLS is biased but consistent. So in summary, if you ILS, it's applied for the just exact identify. 2SLS is for just exact or and over identified. LIML for over identified. 3SLS is over identified. Instrumental variable methods over. So 2SLS method generally we are using in simultaneous equations for the estimates of the parameters. And ML is there. It will almost take more 30 to 35 minutes. So almost the time is almost up. So in these two methods, OLS and ML, the simultaneous equations, we conclude that our presentation over here, because more time will be take almost one more hour will be taken for the MLE. Any problem with respect to this for participants? Back to host. Please, any problem from in both the things?
Sir, from participant side, it's okay. You can continue, sir, because it is most required or it's very important topic as concerned to examination. So please continue, sir.
Shall I continue?
Yes, sir.
Hurry.
Because this is most important pattern, sir.
Okay. Okay. Thank you. If your interest would like to be good LM, maximum likelihood method. The concept, as we seen, that is in the OLS method. Yes.
If you have more time, sir, you can take, sir.
Hello, your
Sir.
voice is not clear, sir.
Sir, actually, host has no problem, sir. They are saying you can take the means you can expand the session also. They have no problem, sir. You can continue, sir. I request all the participants please say yes because this is most important topic as concerned to our examination. So we can adjust the 30 minutes or 1 hour time.
Hello,
Hello.
participant.
I'm audible.
Yes, sir. Yes, sir. Your voice is clear.
Yes, sir. Yes.
Okay, okay, okay. Okay, continue with the will you please give rights to this screen sharing?
Yes, sir. You are co-host now. You can share the screen.
I did, sir.
Just a minute, I have a Hello, sorry for disturbance. Actually, due to some of the office call, I was not getting. Please share. Please allow to share the screen.
Yes, sir.
Okay. Okay. And sorry again. Sorry. So when we're talking about the maximum likelihood method, all the methods have their own advantage and disadvantage. And every method is applied in certain condition, because when you are for the vertical direction, you go with the OLS, you are having the bidirectional relationship. You can go for the simultaneous equations, and when you want to get the maximum probability from your sample, then you go for the MLE method. The MLE method covered two words, maximum and likelihood. Likelihood is directly related with the probability distribution, means how much probability of that event occur with the maximum, means a maximum probability of occurring that event. That is called the maximum livelihood, and that's why it's called the maximum livelihood method. Meaning this from selected sample from a given population, which estimates population parameter with the maximum probability. Because we are not going to be directly go for the analysis of the populations, we are drawing some sample from the populations, and we are assuming that beta cap is equal to beta. So up to at that level, that representations of population of that particular sample at a particular point, I identify that point, that we are using for the maximum livelihood method. A method of the point estimations with some stronger theoretical priorities than the method of OLS. OLS at that time we will not do power, because it's with the unidirectional and with your properties. At that time, at a particular point, if you want to get, then it's the maximum livelihood method will be used. So mathematically, that random sample have X factors, X1, X2, Xn from the populations. Vector X contain X1, X2, Xn value, and each observation are mutually independent as per the OLS assumptions. So X1 and X2 up to Xn's observations, they are mutually independent. There is no relationship between. So the covariance of X1, X2 is equal to 0. We are using two things in the maximum likelihood method. This we are find the joint density function, because this joint density function will be giving you will give your maximum likelihood function parameter to estimation. This joint density for density is the likelihood function defined as the function of unknown parameters vector theta, where y is used to indicate the collection of the sample data. So in sample, the parameter theta that has been maximized up to that level, so it represent the sample, it represent the parameters estimates of the sample. So probability distribution PDF is called the probability distribution functions. The function is x is a q1, q2, qk. X is the variable. So we have population of k parameters from which we can select a random sample of n unit. Now we can select the values of q1, q2, qk variable, and now we solve by the jointly probability functions. The joint probability joint density is the likelihood function defined as the function of the unknown parameter theta, where y is used to indicate the collection of the sample data. We can have the PDF probability distribution functions x x2 q, q2, and qk variable. X is the observations and q between the variables. Out of that, we can find out the joint distribution function, joint probability functions with respect to the theta, and for the y we can collect it the sample data. Joint probability functions identified the xi for function of xi theta for every I is equal to 1 to n. So this is follows the xi follows the joint distribution function. The joint distribution function is the fi xi theta for xi. We can write this common PDF functions for each xi. For xi is x1 follow the joint distribution function, x2 follow the x theta joint distribution function, x3 follow the up to n, and xn follow the joint distribution function of x and theta. Where x1, x2, x3 marginal PDF is joint distribution function of the x and theta up to xn. Because population same for from which xi sample is drawn. So joint distribution function for x and theta is the same for the different level of the observations. Now we can identify the joint distribution functions for equation. For PDF xi follow the joint distribution functions x to xn. By theorem, multiple probability applications about the PDF, then the joint distribution function x theta is equal to x1 theta function of x2 theta up to function of xn theta. In the compact form, we can write that pi means the product of function joint distribution function of xi theta. This function is called the likelihood function. Is called the joint PD of a random sample. If you are putting the L means likelihood, then xi theta is the likelihood function. What it called? It shows the probability of the sample observation which contain theta in the sample which need to maximize for the theta. The next step from this functions, from this L xi theta, from this function, the next step is we are trying to maximize the likelihood function L with respect to theta and find the values of theta which maximize the probability of the selected sample become most probable. Means if you have from the publicity, if you are having the different kind of sample and you are find the most probable sample with respect to this maximum likelihood method. By maximize the likelihood function joint density function of xi theta. Xi is nothing but your observation. By example, xi follow Poisson distribution. So xi follow the p Poisson distribution lambda, where every I is equal to 1 to n. Xi is the same observation which follow the Poisson distribution with parameter lambda for every I is equal to 1. Now likelihood functions write in that manner L in bracket x as usual lambda rather than theta. So that PDF become its PDF become x1 lambda f x1 lambda into f x2 lambda up to into f xn lambda. This random sample is follow the Poisson distribution. If it is a normal distribution, then mu and theta will become. If it is another distribution, there are many distributions are there, formulas are there. You can put it this value in that formula and try to find out the values of. It follows the Poisson distributions. Then its Poisson distribution function for f xi is equal to e raised to lambda minus lambda square into lambda raised to x and xi factorial. Now develop the joint distribution function the xi follow the p lambda for every 1 to n and a Poisson distribution function is equal to this function that has been derived from this Poisson distribution functions e raised to minus lambda rather than lambda raised to x x1 divided by x1 factorial into e raised to minus lambda raised to x by x2 factorial into in continue summation of e raised to minus x lambda raised to xn and summation xn. This is a function that has been derived from Poisson distributions if the sample is follow the Poisson distribution. Now develop the PDF Poisson distributions for lambda. So is equal to e raised to lambda x1 as we discussed. Now write into the single term from the base and exponent of the properties shows that when the base is common, then we added the properties. So L means livelihood function L x lambda is equal to e raised to lambda raised to x1 x2 xn because in the first function you can say that the base is the same lambda up to xn lambda. So it should be a summation that has been taken by the summation of xi lambda, and e raised to n minus, because it is n times of the lambda in e raised to, so n into lambda e raised to summation xi by xi factorial. Now we minimize likelihood, maximize likelihood function L for the parameter theta. As per the maxima and minima function, there is a rules that if you go for the maxima, the rules that your first derivative is equal to 0 and second derivative is less than 0, means it should be a negative function. So if a theta by if delta by delta theta L is equal to 0 and delta 2, means the second derivative delta square by delta theta square is less than 0, this called the maximum likelihood equation. This maximum likelihood equation would be used for the further analysis. The condition for MLE, this first derivative should be 0 and exist. Second derivative should be negative and exist. The property of the MLE is under regularity. M1 is consistency. M2 is asymptotic normality. M3 is asymptotic efficiency, and invariance properties. These are the very different properties with respect to A. You can go for this equation theta with respect to this equation. Take the first derivatives, then it should be a x bar. If you take the second derivative, then it should be a negative x bar. So both the condition that has been fulfilled, that it's a maximum function. If it is the normal distribution, you go for the mu and sigma, and you get the values of maximum likelihood functions, and in that way we are find the maximum likelihood function. Thank you very much. I was very hurry. There are some other tasks with me. Thank you for giving an opportunity. Any questions with respect to that? You may ask right now. We have the 5 minutes, or you may text, or you may contact on my mail ID. I have already given in the first. I have already this alpesh.lewa@vanue.in. And welcome to all of you. Thank you.
Thank you so much for sir your valuable time and this session. Definitely it will help to our participant for their respective examination. Thank you so much, sir. And I would look to thank for all the participants also for their active participation. And before
Thank you so much, sir,
this
for
session, I request all the participants, please join before 3:30 for our next session with Dr. Nandini Shah, ma'am. Thank you all of you once again.
Thank you so much, sir, for very informative session. Sir, I have just one question regarding the MLE. Sir, what kind MLM means maximum likelihood method? What kind of MCQs or what kind of objective type questions may be asked on the maximum likelihood method?
Actually, there are their properties may be asking, then log for their generally their properties, their assumptions, and based on that, because there are different distributions, Poisson distributions are, normal distributions are, chi-square distributions are there. So on at that time, and so at that time, what their estimates of the MLE. That suppose in the Poisson you can go for the first and second derivative, you will get the x bar is your MLE. So your mean of x bar is your MLE. Your second derivative is negative or positive. That kind of the questions may be asked in the MLE. Yes.
Thank you so much, sir. Thank you.
Yeah. Thank you to all of you. Thanks.
Thank you, sir.